Okay, welcome back everyone. I deeply apologize for the disruption. We had some technical difficulties. So that is why in the previous video, we actually stopped, at subsets, the explanation I was doing. So now what I'm going to do is, now I'm going to explain to you about infinite sets. Now we're going to move on from there. But don't worry, as soon as I get to the concept of subsets, I will go over this concept again that I was explaining in the previous video. So you don't have to worry at all. So just relax. You don't have to worry. So this is a very interesting. This is an interesting type of set because you get many challenging mathematical problems to solve. So as I already told you, finite sets. So finite sets contain a definite number of elements. Okay? So like I said, you can say finite sets have a definite number of elements, or you can say contain, whichever word makes you happy, you can just go ahead and do that. So now, I'm going to give you some examples. So I think the best example that I can really give all of you, the best example that I can give all of you guys is this one, But what I'm going to do is I'm going to give you two more examples first, just so that you get the hang of it. So what we're going to do is I'm going to just straight away dive into the examples. So I don't think we need this anymore, so I'm going to dive into the examples. Okay. So, like I said, guys, I hope you're copying everything down. I hope you're doing that. But anyways, so let's take one example. So this is an example that we have, guys. Okay, so this is an example. Now remember, guys, if you do not put this notation and you just put the x's, then you're gonna lose marks in an exam. So make sure you do all of that. So okay, guys. So x squared minus 9, okay, equals 0. Okay, x squared minus 9 equals 0. So this is a finite set. Now I'll explain to you why. Now my main concern is, can you see this equation or not? That's what I'm going to really look at. Yes, perfect. You're able to see this equation. I just went back just to see if I'd written it big enough or not. Otherwise, it will seem like a midget on the computer and it won't happen. So, what is the answer to this finite set? What is the answer? So, as all of you know, guys, as all of you know, this is the answer to this. Okay, so you have equals 0, and then you have x minus 3, x plus 3 equals 0. So this is factored. So x equals 3 minus 3. So then ultimately the answer to this finite set will be this. Okay? This is the final answer here. Negative 3, 3. Okay? This is the answer. So this is practically the first example. Okay? So this is a finite set. Okay? Because it has a definite number of solutions. Okay? So you can just copy this down. I mean, it's not something very hard. I'm just giving you an example. This is just a random example. This example can be done in 2 seconds, so I'm showing. I don't think I have to do a question that will take the ends of the year to do as an example, because then it will just lose the instance. that I'm trying to explain. But anyways, let me now take example number 2. Now example number 2 is not as hard at all. It's not as hard. It's even simpler than this, but it's probably a little similar. So let's say, okay, this is it. So x minus, okay, x minus 9, okay, equals 0. Okay, so this is it now, x minus 9 equals 0. So what's the solution to this example? So this example has a simple solution as well. So you first equate them to 0 by using the null factor law. I hope you know what the null factor law is. You equate x is to 0 and then you equate x minus 9 is to 0 and then x equals 9. So then the final solution is, this has two definite solutions, 0 and 9. So this is the solution. So far, I have discussed quantitative problems, guys. I have discussed quantitative problems or quantitative examples. Now I'm going to discuss some qualitative examples of finite sets. Qualitative examples. Now the best qualitative example that I can give you, the best qualitative example that I can give you is the one that I'm about to write down. I don't have to write it down, but I think you guys should also write it down, as you might also forget. Okay? So let's say the population of the world. Okay, guys? Population of the world. Okay? Population of the world. And we all know what is the population of the world. 7.6 billion, and it's increasing. So this is really a finite set. 7.6 billion, that's it. You cannot write 7.6 billion plus. No, that will become an infinite set. You have to just be exact. 7.6 billion, period. That's it. No questions asked, nothing more than, population of the world. Or to make it even simpler, if you still are confused, maybe the population of the country where you live, like I live in India. So the population of India is 1.2 billion. So 1.2 billion as being the population of India would be a finite set. But if I say the population of India is 1.2 billion and counting, then that will become an infinite set because it is still going on. It is still going on. So that's just how it is. So, like I said, when I do the exercise questions, you will understand this in a more deeper manner. So don't really worry about it right now. Don't really worry about it. So now what we are going to do is we're going to talk about infinite sets now. Infinite sets are not they're not scary either. They're only scary if you make them scary. Okay, so what are infinite sets? Okay, guys. So infinite sets. Okay. Sets have an indefinite number of solutions. Okay? They have an indefinite number of solutions, infinite sets. Okay? So let's take some examples. Okay, let's take some examples. So I'm going to take some examples now. What examples can I really take? There are many examples that I can take. So I hope you copy this down. So let me just see if you can see this properly right now. From a very far angle, yes, you can see this properly. So let me take one. Let me do it the other way. Let me take one qualitative example first of this one. Then we take two quantitative. So infinite set. So what is an example? The best example, guys, is the set of all prime numbers. Okay, set of all prime numbers, guys. So is an infinite set. Prime numbers, because we still are not able to count how many prime numbers there are in total. Yes, we know the number of digits the largest prime number has, but we just don't know. We just don't know all the prime numbers. Why? Because you can just add and subtract one to do the multiplication of prime numbers. All in all I'm saying is that you all know there are an indefinite number of primes, So that is why the set of all prime numbers is an infinite set. So now I'm going to take two other quantitative examples which are going to be a lot easier for you, and you'll easily be able to understand them. Quite easily will you be able to understand them. So let's really move on now. So I hope, like always, you copy this down. I hate to emphasize it, but the reason why I'm emphasizing it again and again is because if you're new to my channel, then it'll take time for you to get the hang of it. But don't worry, you will get the hang of it, and I'll also stop repeating myself. But anyways, so let's take another example. So this is a very simple example that I'm about to take with you right now. So you have x to the x, okay, very simple example. Y equals 2x. Okay, y equals 2x, comma, where x is an element of the real numbers. Okay? Okay, so this is what it is. So basically this has infinitely many solutions. You can assume y to be 0, then x will become 0. Okay, because when y is 0, you have 2x, and then obviously x becomes 0 because you divide 2 from both sides. You divide 2 from both sides, and what does it become? It becomes 0. If you take x equals 1, you take x equals 1. Sorry. Okay. If x is equal to 1, you have, with x is equal to 1, so y is equal to 2. And this way, guys, this can go on forever because it's all real numbers. And I'm sure by now, all of you know what real numbers are. Maybe if you're in the US, you still don't know, what all prime numbers are. But if you're studying in India and you're in class 11, you should know this. You should know this. Don't worry, guys, I'll also go through this with you later, but right now, what's more important is this. So now let's take the next example. Now the next example is a lot more easier. It's a lot more easier because the explanation is a lot more simpler. I won't have to, I'll have the opportunity of becoming more dyslexic, in explaining the next example because it's going to be a little more obvious. So I wouldn't mind if you accuse me of being a dyslexic idiot for having the inability of not explaining this question. So let's go ahead and do it. Okay, so x for example, R. Okay? So, guys, mind you, this is an R, it's not a K, and not the best one. Now that looks more like an R, that looks more like a R on the internet. Anyways, so everything's on the internet, anyways. But anyways, moving on. So, as all of you know, guys, that x squared plus y squared is equal to 9. So, basically, guys, this is a circle. This is a circle, okay, with the center at the origin, I'm assuming. Okay, but it's basically a circle. Don't worry about everything else that I'm saying. Just take my word for it. This is a circle. This is a circle of the form x squared plus y squared equals r squared. Okay? Just take that. But don't confuse this with Pythagoras theorem. Okay, don't confuse this with Pythagoras theorem, because if you do, oh my god, you're gonna get into deep waters which you'll not be able to come out of. But anyways, so here what it's trying to say, guys, is you can again have infinitely many solutions. Like x can be 3 and y can be 0, and 3 squared is 9, okay, plus 0, so equals 9, isn't it? 9 plus 0 equals 9. Or x could be maybe 2 root to the power 2. Wait, okay, maybe I'm screwing up. I don't know. 4 root. Okay, wait. 4 times